We are increasingly seeing websites serve everything over HTTPS. And one of the things that means is that they need to have a mechanism of handling it when someone requests a resource via HTTP. Now they typically do this by taking the insecure request and then redirecting it to a secure resource. Let me show you what I mean. I'm going to paste in this URL for American Express. Now note the URL, and in particular the scheme of the URL. It's HTTP. I'm now going to load this website, and you see how we end up in HTTPS. So clearly somewhere along the line, that HTTP request has been translated into an HTTPS request. Let me show you how that happened. I'm going to open the DevTools with F12. We're on the Network tab. I'm going to enter in HTTP again, and let's load the site again. We can see the request going down here. I'm going to scroll up to the top, and we'll see that the first request up here resulted in a 301. We can click through to this request, and we see here in the summary, in this general section, status code 301 moved permanently. And then if we scroll down a little bit and we have a look at the response headers from the server, we can see a location directive, HTTPS www.americanexpress.com. So our HTTP request did successfully go through to the server, and then the server said, hey, I would actually like the browser to make an HTTPS request. So it responded to the browser with this initial response, and if we close the headers here, we can then see the second response resulted in an HTTP 200. And if we drill down on that, we will indeed see that the request URL uses the HTTPS scheme. Now there's another trick here as well I want to show you, and it's this. I'm now going to paste in the URL again, and this time we're going to take out the scheme. So no HTTP. We'll just start with www, and we'll load the site again. Now we end up at HTTPS, which is fine, but let's have a look at what happened. We'll scroll back up, and here we see the same pattern again. We see an HTTP 301, which if we drill down again, we'll see also has the location attribute to send the browser back to the HTTPS scheme. Now on the surface of it, this looks okay. And if we can actually get to this point where we have the HTTPS website loaded, then all of our browsing from here on in is encrypted, which is good. The problem, however, is that initial request. That was an insecure request, the one we've got highlighted right here. A man in the middle, so anyone that can get in the middle of the traffic, could have intercepted that request and manipulated it. So for example, they could have redirected the user to another site, to a phishing site, for example, and then asked the user for their American Express credentials. Alternatively, they could have used an attack such as SSLStrip, where they sat in the middle and communicated backwards and forwards securely with American Express, and then also backwards and forwards with the client insecurely, taking the secure response from Amex, sending it to the client insecurely, taking the insecure request from the client and sending it to Amex securely, and playing the whole thing out in that fashion. Now this is by no means an American Express problem. This is the way the web works. If you explicitly specify the HTTP scheme, or don't specify any scheme and all browsers will default to the insecure scheme, then that request is at risk. You have to get past that first request and get a secure response before you can have confidence in the integrity of the connection. And this is precisely the risk that HSTS sets out to solve. So let me now go and show you how HSTS solves this problem.